Hi, we're Team 6A and we're conformed of myself, Maria, Spencer, Alend, and Mackenzie. To correlate with the VIBE program's theme of global health, our project aims to design an affordable and easy-to-use product which will detect lead in waterways in a qualitative and quantitative way to ensure safe water consumption. Lead poisoning occurs mainly because of the corrosion of plumbing materials that contain lead, such as lead pipes, faucets, and fixtures. The concentration of lead in the water depends on multiple elements such as the water acidity and alkalinity, water temperature, the amount of wear in the pipes, and the presence of multiple other minerals. Lead poisoning is a current issue that the world is facing. The World Health Organization estimates that about 1 million people die each year from lead poisoning, and millions more are exposed to low levels of lead that cause the following effects. In children, it can affect their brain and nervous system as well as slow their growth. It can also create learning and behavioral problems, hearing and speech impairments, and other issues pertaining their physical and mental development. In adults, it can cause high blood pressure and increase the risk to have heart attacks and strokes. Additionally, it can decrease bone mineral density and cause damage in their gastrointestinal and reproductive system. And like mentioned before, for children, it can also cause numerous behavioral and neurological issues in adults.
Current ways to detect the presence of lead in water include various forms of spectrometry, colorimetry, and voltammetry. However, these techniques cannot be used in the field or by the everyday person. These techniques require that the tests be done in a laboratory and by a trained technician. This means that the test results have a long lead time, and to get a test done is costly. All this is even assuming that you can find the proper resources to get a test done. The other testing methodologies that can be done at home and on the field do not have reliable accuracy and cannot measure down to the concentrations required to be considered safe by the EPA.
In order to address these issues, we have designed an at-home test using tap water and sodium phosphate. The most common form of lead in water is lead 2+ ion, which will react with the phosphate group of the sodium phosphate after the sodium phosphate has dissolved in the water and lost its 3 sodiums. The reaction between the lead and the orthophosphate will yield a heavy yellow precipitate that will sink to the bottom of the vial. Due to this, the vial should be capped and turned upside down during the reaction. This way, the precipitate can be drawn out of the vial by the syringe through the puncturable cap to introduce the precipitate to the heavy metal detector in the case that a precipitate is hard to see.
Each kit contains one 60 milliliter syringe, 5 packets containing 1 milligram of trisodium phosphate, 1 sensor, 1 LED display, and 1 2-ounce vial for a total cost of $3.08. Compared to the pre-existing solution of sending in samples to be tested in a lab, our design is valuable in that it is affordable, easy to use at home, quick in obtaining clear and simple results, and each kit allows for multiple uses.
Future steps for our design include further in-depth research into the aqueous chemistry of lead, getting a working prototype made, real-world testing, and iterating on our design. After finalizing the function of the product, we would need to optimize it for mass production so that it could help anyone around the world.
Thank you Professors Afzal, Mensa, and Billier, and all additional faculty from WPI and beyond, who are part of the lectures and activities throughout the VIBE program.